Okay, everybody, welcome to the second part of your first night of homework for algebra, my Algebra All-Stars. You're really going to live up to that name, I'm really confident. So this portion of your homework assignment is about algebraic translations. And if we think about it, math really is kind of its own language. Some people call it the universal language because numbers are going to be the same no matter what language you're actually speaking. But what you need to glean from this lesson is something that you will find on the SOL. When we are presented with an algebraic expression or even an equation, we get the numbers. We get numbers and we get the operational signs, and we know how to move through that expression or equation in order to find the value. But sometimes you are going to need to be able to express that same numerical expression in words. Or you will be presented with a word problem and need to know how to flip it back into actual numbers so that you can solve it. So for the SOL, you'll have to be able to prove that you have proficiency in doing that, in translating from words to numbers and from numbers to words. So this video is going to tell you how to do that. This can be tricky too. For some reason, this is a hard thing for everybody to grasp. But if you know what to look for and you kind of take it piece by piece and then put the pieces back together, you guys will be golden. So remember from the vocabulary slideshow, unlike equations, algebraic expressions don't contain an equal sign. And right now we're just talking about expressions. So equal signs cannot be solved for a single value. They can just express a potential value. If we don't have the balance on two sides of the equal sign, we can't solve anything. All right. We already know the parts of an expression, right? We talked about this in the last lesson. The number of items in the expression separated by an operation. This is called a term. When we talked about polynomials, binomials, trinomials, terms separated by an operational sign. A number by itself, you guys remember what that is? Starts with a C. Constant. A constant is a number hanging out in an expression by itself. A letter that symbolizes an unknown value. This should be a no-brainer, you guys. This is a word that we are going to say every single day in class, variable. And then a number that is multiplied by a variable or stuck to the variable, right? What happens when two roommates share a house? They cohabitate. So a number that is stuck to a variable, sharing that space, is the coefficient. Coefficient. Y'all, that's not spelled correctly. But that's why I'm a math teacher, not an English teacher. You know what I'm trying to say. We're going to move on and we're not going to judge. Okay. So when we are translating between verbal statements and algebraic expressions, or verbal, words to numbers, you have to be able to pick up on some keywords so that you understand what mathematical operations are being represented. We can't just throw a bunch of numbers on a piece of paper and expect that to make any sense. They have to be tied together with operation. We have to be getting some direction from that expression or from the equation so that we know what we're being asked to do. So really the first step in algebraic translation is being able to understand, what am I being asked to do here? And you will figure that out by picking up on some words that will mean one of four things. You're either being asked to add, to subtract, to multiply, or to divide. And to be honest with you, you will probably be asked to be doing more than one of those things in each of your translations. But we're going to list out in this table some words that you will see and be able to register, okay, that means add, or that means subtract. So the first one we're going to put here, it's kind of a no-brainer. If you see the word add, they're asking you to add. You may also see the word sum. The sum is the number that you get when you add two other values together. So sum is something that you might see. You may see increased by. I had one number. It was increased by another number, so I added those two numbers together. More than. okay? 5 more than 7 is the same thing as 7 plus 5, 5 more than 7. Same thing here. 7 increased by 5, 7 plus 5. Or the sum of 7 and 5, well, that means 7 plus 5. Okay, it all means the same thing. And also, you may see exceeds, probably not as often, but that's one I want to throw on there just in case. Plus, we know that. 7 plus 5, well, that means add. And then also gain. Exceeds and gain are probably two that you'll see very rarely, but they're worth putting on our table just in case. Sum, increased by, more than, those you'll definitely see. Plus and add, I mean, I hate to say duh, but duh. Okay. Subtract is the same thing. You know, we subtract or minus. 7 minus 5. Difference. Difference is kind of the counterpart to sum. Sum and difference are often seen together quite often. Decreased by. You could see we had increased by, so decreased by. That's a possibility. Decreased by. Fewer. Along the same lines as decreased by, you may also see reduced by. 7 reduced by 5. Reduced by. Now I'm all self-conscious about my spelling. Okay, and then less than. I want you to put a big old asterisk and a big old box around less than, because there is something very important about less than. And we are going to revisit this when we get down to our important hints. But I want you to get it in your mind that this is one that I want you to flag. Okay? And we'll talk about why in a second. Okay, multiply. Multiply, obviously. If you see the word multiply, it means multiply. And times, that's another word that we use to mean multiply. 7 times 5. Sum, difference, product. If you see the word product, that means the number that you get when you multiply two numbers together. The product of 7 and 5 is 35. It's asking us to multiply 7 and 5 together. So multiply, times, product of. That's also an important one. And it seems strange, but if you see, I'm trying to think off the top of my head how you would see that read, but you know, 2 of a number means 2 times that variable. So you'll see of, and just know that of means multiply. You may also see things that are specific to the factor that you're multiplying by, like twice, triple, or double. Those will be a little bit less, that'll occur a little bit less. These guys, multiply, times, product, and of, those are going to be the ones that you see most often for multiplying. And then divide, you know that. Per, quotient. These words, sum, difference, product, and quotient. All of these 4 words refer to the answer that you get. When you add numbers together, you get the sum. When you subtract a number from another number, you get the difference. When you multiply 2 numbers together, you get the product. And when you divide a number by another number, you get a quotient. So those 4 words are words that are specific to the answer for those operations. So those are good to always have in your mind. Continuing on with what you might see for dividing, you might see, oh, I already wrote per. Sorry about that. Fraction, ratio of. When I talk about a ratio of x and y really just means x over y. Well, that's x divided by y. right? Just like a fraction. Ratio of 1 and 4, that's 1 over 4. 1 divided by 4 is 1/4. The word fraction, again, split into, that's one you might see. Rarely, but we'll put it on there. Or divided equally. You might see that also. Divided equally. Okay, so these are all potential words that you need to be able to recognize and be able to put a sign, plus, minus, multiply, or divide. So that when you're reading the verbal statement and you come by one of these words, you know, okay, I'm going to replace that word with a sign in my translation. All right, so work on that little table and try and memorize that if you can. And definitely these 4 words, definitely less than. We're going to get to that in 1 second. All right, important hints to remember. When you see a number, okay, if they are telling you a number increased by 5, that's where you're going to put the variable that you're using. So a number increased by 5 would be x, if we're using x, plus, because we know increased by is about adding, 5. A number increased by 5, x plus 5. All right, here we go. Put your big old star right here, or whatever that is. Less than reverses the order of what you read. So if you see 6 less than x, then the x comes first, you get a minus sign for less than, and 6 comes after. 6 less than x becomes x minus 6. Okay? 6 minus x would just be 6 minus x. But if you see less than, you know that what you're reading needs to be flipped. And that's the only time that that occurs. So that's the one phrase that you need to have red flagged in your brain. If you see the words less than, whatever you're reading has to get flipped around. And I can almost guarantee there will be a question like that on the SOL. Sorry. And then also check for commas. This is a little less frequent in what you'll see on the SOL, but they may be there. If they are present, they will help you group the terms and decide where to put operations. So 5 times, comma, a number increased by 5. We've got 5, and then we know that there's an operation that's going to happen here. A number we know is our variable. Increased by means plus, and then 6 is going to be our constant. So 5 times, comma, a number increased by 6 becomes 5 times that number increased by 6, the variable increased by 6, as opposed to 5n plus 6. If there was no comma here, then you would get 5 times the number plus 6. But because there's a comma, there's a separation there, and it's going to be 5 times will be its own group, and a number increased by 6 will be its own group, which is what we have here. All right? So let's try some examples. Bring you back down here. 5 increased by 4 times a number. Okay, so we've got increased by, and we know that that's plus, and we've got times, and we know that that's multiplying. And we've got a number, so we know that that's where our variable goes. And I'm going to use n because the word number starts with n. So 5 increased by 4 times n is 5 plus 4n. Okay, we took 5 increased by 4 times a number. We don't have to put a multiplication sign in between 4 and n. We know if they're stuck together, that translates as multiplication. So don't worry about adding an extra sign in there. If you want to, it's fine, but you probably wouldn't see it that way as a choice on the SOL. 8 less than twice a number. Okay. Up, 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 red flag. That means what we are writing is going to be flipped around. 8 less than twice a number. So this twice, remember, means multiply. N is our variable. Less than is subtraction, but the whole thing has to be switched. Okay, so I'm going to put my subtraction sign here. What I'm reading, 8 comes first. Well, that means 8 will come last because we're flipping. Twice a number, 2 times n, that's going to come in the front because it's in the back in the sentence. So 8 less than 2 times the number. All right? I know that's a weird thing to wrap your brain around, but you just have to remember when you see less than, switch it. Whatever's in front of less than goes in the back. Whatever's behind less than goes in the front. Okay? 3 times a number, comma, decreased by 9. So that means we've got 3 times our number decreased by 9, minus 9. This is minus. And we've got a comma there, so we're grouping those things together. The product of 4, so multiplying, okay? And then we are grouping what comes after, a number decreased by 7. So we are multiplying 4 times whatever's left in this group, a number, which is my variable, decreased by, subtraction, 7. Okay. 4 times n minus 7. All right, the width of a rectangle, which is 7 less than its length, L. Well, this is very wordy. And really not all of this is even going to get translated into what we are going to write here. The width of a rectangle, which is, well, this really just means the width equals 7 less than its length, L. What happens, if this is my real statement, when I see less than, I'm going to flip. Whatever's behind comes in front, whatever's in front comes behind. So if I've got the length, L, let me make it loopy so it doesn't look like a 1, L minus 7. That's the width of the rectangle. W equals L minus 7. Okay? And then this one's fun. A number repeated as a factor 3 times. We know that a factor is something that we are multiplying against something else. So a number, meaning the variable, repeated as a factor 3 times. Factor is multiplying, so we are repeating the number as a factor. N times n times n. Or you could write, if you remember from your exponents, from the vocabulary, n to the third. Either one of those would work. All right. I know this is a crash course. I know that it can be a little bit confusing for these, you guys. You just have to study that table, and then we're just going to practice over and over and over again. We will work on this tomorrow in class. Anything that you have questions on, be sure to write down in your question sheet. And that's it for your first night of homework. Great job, you guys. I think it's going to be a really great way to set up our semester and make sure that you are bringing your questions to class. Good job.